Hello everyone, I'm Liam, and today I'm going to be talking about going and supercharging your API monitoring by using Guzzle Middleware. My name is Liam Hammett, and if you couldn't tell already from the fact that I'm at a PHP meetup, I have a scraggly beard, and I'm giving a talk about PHP, I'm a PHP developer by day, but I'm also a PHP developer by night, which you might be able to tell by the bags under my eyes that just don't stop coding sometimes. One of the things that I like to build during my, while I'm not doing my day job, is building tools that make development life a little bit easier. So one thing I built is called CPX. It means Composer Package Executor. It's basically a way to just run Composer packages without having to install them into your project or as a global dependency. It's kind of like NPXs, but for the PHP ecosystem. I think it's pretty cool, and you should check it out. I've also written a VS Code extension for PHP that brings a bunch of additional functionality, some of the more powerful refactoring tools and features that you might see in something like PHP Storm. So if you use VS Code, maybe you want to check that out as well. That's a really awfully sized image. You can find both of those on the VS Code marketplace and on cpx.dev. If you want as well, if you use either of these, I have stickers for those with me as well. But during my day job, this is a really awfully sized screen resolution for this, but we'll bear with it. During my day job, I work at a publishing company called Future. And at Future, we run a bunch of really big name brands. You might not have heard of Future itself, but you've probably heard of something like Tech Radar, or if you're into music, maybe Louder Sound, or if you're into cameras and photography, Digital Camera World, or all these kinds of things. We have like 150 different brands, and most of them are running on one platform that is like a multi-tenant application that's running all of their websites. And I find it really hard to talk about what exactly I do a lot of the time, but I think I can distill it down to something pretty simple. A blog. I think basically everyone here has built a blog at some point before, right? You have a list of articles, you might have a homepage that lists all the articles out. You click into one of them and you can see who wrote it, and you start to read the article. And you think, how is that a complex application? How can that be like a job to run that for a bunch of sites? It's really simple. But it gets a little bit more complex when you start to add features into this. Rather than just having a database that's displaying a list of articles, what if you come along and you add a search bar to the top? Well, you might just use the database to do the searching initially. But if you have more complex articles or more complex data types, you might step away from the regular database to do that and use a dedicated search tool, something like Algolia or Apache Solr or Elasticsearch. So you might end up making an API call there in order to power that search. And then you scroll down the article as well, and you might see at the very bottom here this sign up and pay to continue reading. Well, somewhere along the line, some of the business has come along and said, hey, we need to paywall some articles. These are like really premium pieces of content. So we need people to sign in and pay to continue reading them. So if you think about that, that's quite a lot more complex already. Now you need to have authentication and deal with users, and you could build that into your own database. But again, if you're a big enterprise, you might end up using something like Auth0 or WorkOS or some other API to manage your authentication and your users. And then you've got to deal with payments, and you're not going to handle that yourself. So of course, you're going to be using Stripe or PayPal or Chargebee or one of these other platforms and calling APIs through that. You scroll further down the page again and you see, well, we've got a discussion at the bottom. There's comments on the page. And again, you can handle that in the database, and it's pretty simple to do. But if you're dealing with the scale we are, we've got thousands of comments coming in every single day. We need moderation tools. We need to be able to promote the best comments to build a good community. You need to be able to reply to comments and report them and have a whole host of things. Comments suddenly get really, really complex if you've got lots of them to deal with. So you might use an API like Viafora or Disqus or something like that. You scroll down again and you see there's this related article section at the bottom. And well, this is really simple, right? You just show some articles that are in the same category or have the same tag, or maybe just the latest articles on the site. But actually, when you're dealing with the kind of scale we are, we're serving tens of millions of views to these pages every single day. So when people click through to a second page, that extends the time on the site. It means they're more likely to interact with things. It's more likely to give us revenue through ads and through e-commerce links and stuff like that. So we really want to optimize these related article sections. So we're not just going to make it a really dumb show the next few articles. We're going to really tailor it to try and get people to click on there. So what we've done is we've exported our article data to a vector database so that we can use that to look up and find good matches for other articles that we think people are actually going to be interested in. And you scroll down further and we've got a newsletter here, and no one wants to deal with emails themselves, so you're probably going to defer that to some service you're calling via an API like Amazon SES or MailChimp or something like that. So you can see how really quickly you've gone from a simple blog and you've ended up with this mishmash of different APIs being called, and this is just the start of it. This is just like 10 or 11 different APIs being called, but in a real application that's quite easily going to scale to 30, 50 different APIs that you're calling from your app, depending on what kind of tools you're using, if you're going with microservices or something else. And if you're lucky enough to become a company that's big enough that, you know, overtakes an entire industry, you might end up with a system that looks like this. This is a snap from one of Uber's engineering blogs, and every single dot on here is a different microservice or API that they're calling from their stack. So the question is really, if your application is here, but something's going wrong down here, and that affects your application, how do you track that, and how do you know what exactly has gone on and where something's happened? And it's a really hard problem to try and deal with if you don't know how to deal with it. So we're going to talk about observability. And not just that, but the three pillars that underpin observability, which are logs, traces, and metrics. And these three concepts are things called telemetry. They are bits of data that are being captured about your application, about the APIs you're calling, about basically anything that happens inside your system. And it takes that information and stores it somewhere. And observability is basically the viewing of that data. So you're not just taking the data, you're doing something with it. You can read the data, you can make sure that your system is in top-notch condition, that you're going to be absolutely fine if something goes wrong, and you can diagnose it quickly and easily. So we're going to expand out, and we're going to have a little look at what we're dealing with here. So for telemetry, we're going to be looking at OpenTelemetry, which is primarily two things. One is it's a standard that defines the file format for your logs, traces, and metrics. And the second thing is it's an ecosystem, a set of packages that you can install into your projects and have them consume or export that OpenTelemetry formatted data however you want. And that's really helpful because it's not limited to just PHP. You can have a JavaScript application or a Golang application or a Rust application or Java or whatever you want. And using OpenTelemetry, you can export all your logs, traces, and metrics into the same format so they can all go into the same platform and you can see everything together instead of having to deal with different languages and different ecosystems having their own separate ways to do things. So what we're going to look at with logs, we're going to be storing our logs in a system called Loki. We're going to be storing our traces in a database called Tempo. And we're going to be storing our metrics in a time series database called Prometheus. So we'll get into all of those later. But the thing you'll probably see the most is we're going to be using a tool called Grafana to look at and observe all of this stuff. So how do you get all of those systems running? That's like OpenTelemetry, Loki, Tempo, Prometheus, Grafana. That's 5 different things. You don't want to have to go and run 5 separate things just to get started with this. So Grafana have helpfully put together a Docker container called Grafana OTel LGTM, which means OpenTelemetry, Loki, Grafana, Tempo, and metrics or Prometheus. So if you want, you can go and run this Docker command, and it's going to run an image for you that's going to have all of those tools set up for you, and it will expose a couple of ports there that we're going to be able to go to both push our data to and to go to the Grafana dashboard, which we can then use to see our data. If you're curious about what any of those do, so port 3000 here will be our Grafana dashboard. And then there's 2 ports here that we can push our OpenTelemetry data to, which will then be made available within the Grafana dashboard. So once we've got that set up and running, we need to get into our PHP application to start recording these metrics. So they've provided 2 different composer packages here, OpenTelemetry SDK and the OpenTelemetry Exporter OTLP, which is the OpenTelemetry protocol, or their file format basically. And so by installing these, it will give you a set of classes that you can use to start collecting data in your application and then export it to one of those ports that we just talked about. What they also have, though, is really, really helpful, is this thing called automatic instrumentation. And if you install a PECL package and then require one of these auto packages, so for example, OpenTelemetry Auto Laravel, that will automatically hook into any kind of places that you are calling various things. So wherever Laravel is logging something, OpenTelemetry Auto Laravel is going to hook into that and automatically export those logs from your Laravel application to OpenTelemetry. Same for other things. So if you're running like middleware in your application, this is going to automatically look into where that code is running, and without you having to touch a single line in your code, is going to start reporting that to OpenTelemetry, which is really, really helpful because you don't have to write a ton of code to get started. You can just require a package and get going. But we're going to talk about this in the context of how we call APIs. And I think, who here uses Guzzle to call APIs? Basically every hand in the room went off. So Guzzle is a pretty popular package. It's an HTTP client that you can install with Composer. Install it into your PHP project, and it gives you this kind of interface where you can see, you can create a new Guzzle client, you can make a request, so in this case we're making a GET request to the GitHub API, and then it gives you this response object, which you can call a bunch of things off, like you can get the status code, or get a line from the header, or get the body contents, and it gives it to you in this really nice, fluent way. It's like the gold standard of how to interact with APIs in PHP. And one of the other things is Guzzle, by default, supports PSR7 and PSR18, which is really, really helpful because if you're using something like Apache Solr, for example, I talked about that, we might use that to power our search on our website. You might be using something like Solarium, which is a package for PHP that interacts with Apache Solr. But what you can do is you can pass through a PSR18 client into that, and then any requests that your application makes to Solr will be going through a Guzzle client. And that's really helpful because when we set up the Guzzle client initially, we can pass through a bunch of config. For example, we can pass through some config that says, well, any redirects that you come across, just follow them, and we don't want to deal with 300s ourselves, just give us the final result of the redirect. Or saying something like, hey, just time out after 3 seconds. No API should be taking 3 seconds to return a response, right? So you can configure stuff like that there. One of the things you can configure is the handler. And the handler is basically a callback that gets executed whenever a request is made through Guzzle. And you can start to see how this gets a little bit powerful. So what we're going to do is we're going to create this handler stack, a stack of handlers, and we're going to pass multiple of them through there. And each one of these handlers that we're going to pass through is going to be a separate middleware. And a quick side note as well, if you're using Laravel and Laravel's HTTP client, you can add Guzzle-compatible middleware through the HTTP global middleware or HTTP with middleware methods. So even if you're not directly using Guzzle, you might be using it without knowing it and be able to make use of this. When I talk about middleware, I really like to talk about it in the context of onions because middleware are like layers, and onions have layers. Middleware have layers, onions have layers. So if I'm here making my happy little request to my application, and the root of the onion is the application, I'm making a request over, and of course I'm going to hit that first layer of the onion, the first middleware, before I get into the root of it. And as it starts going through, I can have multiple middlewares in my Guzzle client, And each of those in turn are going to be invoked before I actually make the real request and get the response back from the API. And then when I get the response back, well, it's going to come the other way, isn't it? And at every single point in this, where I'm hitting one of these layers, I'm able to run some code myself and maybe check something about the request or check something about the response or maybe compare the request and the response together. And so when it gets back to me and I become happy because all I've done is made a request and got the response I expected, all of these layers could have done some additional things that I didn't have to worry about in my application code. They were just kind of hidden off in the Guzzle client. So that's really, really useful because you don't need to change your application code to make use of it. So what we're going to do is we're going to expand out this middleware at the top here. And a middleware is basically a closure that returns another closure. It's a little bit confusing. This is just the syntax that you use to define a middleware in Guzzle, but bear with it, we'll get through this. Essentially, the main thing is Guzzle will provide this next variable, and this next variable is a closure, and you can pass through the request to that closure. Now what that returns, this closure is going to return a promise, which means you can then either return that promise, or alternatively, you can chain something onto that promise as well. So in this case, we're chaining on this then method and invoking another closure, which is going to be invoked when the callback is returned. So the very top one here we've got, you'll see we're passing through two closures. The very top one is on a successful response, which is not just a 200 or 300, it's if any response comes back from the API, even if that happens to be a 404 or a 500 or something like that. The second closure is going to be invoked only if there was an error making the request in some way. For example, there was an SSL timeout or a connection issue, or you just weren't connected to the internet when you made the request or something. That's going to invoke this second closure. So they basically do the same things, but you have different data in different cases. So you're not going to have a response object pass through if it didn't actually get a response. So what we can do is we can start to expand this and look at it. We're going to start on this promise here, and we're going to start to add a log line. Pretty typical log line that most of us will have seen in our apps before. We're just logging some info saying, hey, we're making an HTTP request to this URL. And that works pretty well. But what you probably don't know is pretty much every logging system is going to accept a string for the log, but also some additional contextual data in a key value format. So in this case, instead of just putting the URL directly in the text, we're going to split that out into the context information so that we have maybe the method and the host and the path separately. And the reason we're doing this is because later on when our logs go into Loki, we're going to start to see that Loki is a database that lets us query our logs. So just like you're working with a database, you want to try and normalize your data a little bit. You want to try and make it so that you can query that data in an efficient way that you might want later. For example, later down the line, we might not just want to search for a single URL. Maybe you want to find all logs that are making a post request to that API. Or maybe you want to find all logs that are going to this specific host name, because then you might have a different host name for a staging environment versus a production environment, and you might want to track that down in your logging system. So that's why we're going to do that. Additionally, something I really like to do is add in a user-friendly client name to this. So instead of just having the host name and relying on that entirely, I'm going to pass through a client name to say, well, this is the search API that I'm calling. Maybe it's Solr, maybe it's Elasticsearch or something else, but this is the search API. And we're going to see how that's useful to use later down the line. But what we really want to do is make these middleware reusable, so you don't have to define one for every single API you want to use. The real goal is to make a middleware that you can use in all of your Guzzle clients. Maybe you have a builder class that goes and applies all of these middleware and then gives you a Guzzle client back out of it. So the way we're going to do this is, for now, I'm just going to define a client name outside of the scope, and we're going to pass that through instead. But however you build this, if it's in a builder class or something, you'll probably be able to set a client name when you get it and deal with it there. Later down the line then, when we are in our promise and returning a response, let's just log here instead. We've got a log line at the top saying we're making an HTTP request, and a log line after saying we've received an HTTP response. And we can apply the same client name, and we can give it the status code of the response. But this is a little bit useless in itself. We don't really need to know that there was a request made and a response made. We can just join this into one single thing. And the reason this is really good is because in a real application, you might have thousands of requests coming in every single second, or even hundreds or even tens. And if that's happening, you don't know if one log line relates to the next one necessarily. They might be coming from entirely different requests or different processes or something. So it's not always useful to rely on having your logs be sequential, because they just might not be. So instead of making two separate logs, we're going to make a log that just says, hey, this is all of the information about this. We have all of the request information and all of the response information in a single log. So when we look up that log, we have it all readily available. And we're going to do the same on the exception as well, when we have a transfer exception. So the one thing we can't do here is adding in a response status code, because we don't have a response object. So what we're going to do instead is set a response status of 0, which is kind of like a little convention to say, hey, 0 isn't a real HTTP status code. This is just a convention that's going to say something went wrong. There was some kind of transfer exception in this. But it still lets you search up later down in your Loki database, hey, I want to find all the requests I made that had a response status of 0. After we've done that, we can also add additional context information here. Guzzle gives us this transfer exception object, which has a message attached to it. So if we want to find out why this specific response failed, we can add the message to that and look that up later as well. Yeah. So using like Laravel's logger or Symfony's logger or basically any other framework, you're going to be using something under the hood called Monolog, which, if you've not heard of it, is basically another PHP package that standardizes and normalizes all of your logging. And this is a really handy little thing. It lets you export all of your logs in lots of different formats, but it also lets you standardize it and pass through context data and export that context data to those formats as well. So how do we start to look at our logs? It's a bit of a tricky thing. If you're working locally, you might just like tail-f your log file and start to look at that. If you're working on a single server, you might do that as well. But again, that's really hard to do when you've got lots of requests coming in and your logs might not be split up exactly how you want them, and it's not easy to follow. So instead of doing that, we're going to be using Loki, and we're going to be using Grafana to view that as well. So I'm going to go to Grafana, and this is at the port 3000 that was made available inside our Docker container that we ran earlier. When I come in here, I'm going to go to Explore Logs in the sidebar there, and I'm going to set the data source at the top there to Loki. And when I do that, it's going to give me a little dashboard that shows the logs that are coming in. So you can see here I've got a bunch of logs that say making HTTP request. If you click into those though, you can start to see the logs in a little bit of a different format, where it will show you a graph at the very top here that shows how many logs are coming in at any given point in time. And then if you want to, you can really hone in on them. So what I'm going to do here is expand one of these logs, and it's going to show all of the context information that we've recorded there, just like it was a regular database or a key value store. All of that data is available there. And so I can start to look at that and get an idea of what's going on inside my application. And I can use the tools that are available in Loki to really search through those and hone into what I'm looking for at any given point in time. But if I come back to the sidebar and instead of going to Explore Logs, I just go to Explore, this is going to take me to a section where, again, I can set Loki as my data source at the top. And I can start to write here this thing called like a Loki query. And so in this case, I'm going to set the service name to the telemetry times, which is the name of the demo block that we were doing here. And it's going to give us a similar view. This is a timeline of how many logs were happening at any given point in time, and here's the logs. But what I can start to do, it might be a bit small to see, but at the very top there, I've added a little bit of something to the query where I'm saying, well, actually, I want the context, from the context information, I want the client to be the comment API. And now it's filtered from all of the requests coming in to only the requests with the comment API. So you can see how you can start to use these filters to really hone in on specific things. And I can go again and say, well, I'm going to filter to only things that have a response status of 500. And now I've got a timeline that's showing me when all of my API requests to this commenting API have failed. And I can dive into them. And I can come down here and look at them. And again, all of the context information is here. And it's all made available so you know what to search for at any given point in time. Now we've done logging, we want to talk about tracing. So they really go hand in hand. We're not completely done with logging, but tracing gives us a really good approach to be able to look at logs in a bit of a different view. So what we're going to do is we're going to come in and we're going to make another middleware here. So this is the basic middleware we started off with before, and have stripped out all of the logging stuff. So what we're going to do here is we're going to create a tracer provider, which is going to be an instance of the OpenTelemetry SDK's tracer. When we do that, we can create a new tracer with it, or call the getTracer method, which is going to create one. When it does that, that will let us start to build a span. So again, we've got a tracer provider which is building a tracer, and the tracer is building a span builder, and the span builder is building a span. But the span builder, we can set attributes on it. So a span is going to be basically a point in time. It's like if a log is a single point in time, a span is a point in time where something starts and a point in time when something ends, and everything in between there is considered to be inside that span. So when we start to build the span, we can add some contextual information, just like we did with the logs, to note some stuff about what's happening inside that span. So in this case, we're going to say, well, we're going to call this the client name request, or comment API request, or something that's really easy for us to see. We're going to set an attribute here as well to give some additional context. So we might say, well, the request method is going to be a get or a post request. We want to log that here under method. But OpenTelemetry has this really useful thing called semantic conventions, where, again, you don't want to be sending a bunch of really separate, different things between your applications, because you might not be using the same package here and there. You might be using a different programming language entirely to record some information. So if you're using the OpenTelemetry semantic conventions, it gives you the interface that just has a bunch of different constants on it, and those constants are going to be pretty much consistent across every single library they provide. So instead of coming in here and having it say method, what we can do is we can make that say trace attributes HTTP request method. And that way we are 100% sure that this is going to line up with whatever other applications are making traces related to requests. Even if they're using a different language or in a different project, you're going to be able to search up the same kind of stuff. It's normalizing our data, just like we would in a database. We're going to add a bunch more of those as well, because there are a lot of things you can take note of about a request. So we're going to log stuff like not just the request method, but the URL, the network protocol version, the user agent, the request body size, the server address, the port, the path that we're going to. All of that is stuff that we can start to record and make available inside our span so we know what's happening. And then, after we've done that, we can finally start our span and start recording information. So anything after this point in time is going to be recorded as part of this span. So then when we come to the closure in our response and we're starting to get a response back, we are going to start saying, well, we want to set more attributes on this span. So we're going to set what the response status code is. We're going to set what the response body size is. If the status code was between a 400 and a 600, so if it was a 500 or 400 status code, well, maybe we want to report that as an error as well. So you can start to add lots of different information to the span. And then finally, you can end the span. So everything that happened before where we started that span, up until this point in time, is going to be recorded as within that span as and we're going to know stuff about like how long that took, how much time that took to happen, which is really, really useful. And all we know that's happened from when we started that span to when this finished is, well, the request was made and we got a response. So there's one other thing we need to do here, which is, we don't need to do it, but it's really helpful to do, so I'd recommend it if you're looking at this kind of thing. There's this W3C standard called trace context, and this lets you add a little bit more information to your traces and to your spans, so that if you're calling different microservices, if anyone here is using a microservice architecture, it lets you pass information about your tracing back through to other systems, because that way, if all of your traces are going into one collective database, like Tempo and Grafana, like we're looking at, then you might have multiple different applications and you can see all of the traces and how they interconnect here and there. And you know that graph we looked at before where you might be like 3 levels deep in different API calls before something goes wrong? This lets you link all of that stuff back together. So we're going to do that. We're going to boilerplate some code here to match that trace parent standard, the trace context standard. We're going to create a trace parent, we're going to get the trace state from the span, and we're going to pass that into the request as a trace parent and trace state header. So it's not something you really need to worry about, you just need to know it's going to make your life so much easier later down the line when you come to looking at your applications. So now we get to looking at those through Tempo, and we're going to be using Grafana again to help with that. So back in Grafana, when I'm in the Explore section, I'm going to start to set the data source at the top to Tempo, and then that's going to let me start to write a traceQL query here. So it's a slightly different format to what Loki was using, but it's pretty similar. So again, I'm going to set the service name to the telemetry times, and it's going to give me a list of all of the different traces that have been made across my application. And I can start to expand one of these and see all of the different spans that happened inside any one of those traces. But what's really useful is if you click on one of the traces, instead of just expanding it in line, you can get this whole separate panel over to the side here. And it might not be super clear right now, but here we've got a timeline that's showing exactly when something happened, and there's little bars that show when something started happening and when something stopped happening. And so by looking at this, you can now start to see, well, this request took 5.4 seconds, and well, about half a millisecond in that was an SQL insert statement. And again, that SQL insert statement was coming from that OpenTelemetry auto Laravel package that was automatically recording certain information for us. So for free, we're suddenly getting information about how long our SQL queries are taking in any given request, which is really, really useful. And we can click into that again and see a little bit more information. And one of the useful things here is inside this span, we can click this button here that says logs for this span. But before that also, this has automatically applied a bunch of span attributes, so we can see the exact SQL query that was being made there. But if we click this logs for this span, it's going to take us back to not our Tempo view, but the data source is set to Loki, and these are all of the logs that happened inside that single span. So it's not necessarily that request, but it could be from multiple different applications. If you had an API that's calling an API that's calling another API, all of those logs from all 3 of those applications that happened in this very particular point in time for this one request will all be listed here, and you can see all of them here. Similarly, if you're on the log view, you can get the trace ID here, and there's a little link that Grafana gives you that will let you click on that and show the traces for that log. So you can see the request that happened and for any given log, and be able to track everything all the way back and forth. It's really, really helpful, and it's really powerful if you haven't thought about doing that before. So again, clicking into one of those, we've got a request here to PayPal API. Looks like it took about 55 milliseconds. We can see a little bit of information that's going on there. But that's like a really useful thing. And I hope people can see why it's useful. Does anyone have any questions about the tracing and the logging on the spot?
In terms of when would you prefer logging
Yeah, so I think it really depends on if you care about how long something took, probably, or if you care about what happened between a certain point in time. Like, for example, if you have, let's say, a Laravel application and you're rendering a view, the one problem a lot of people have is they're making a lot of queries inside their views and they don't know it. So the controller might be really, really quick, but the views are taking a long time to do something because they're making hundreds of SQL queries. So if you wrapped the view in a trace, you would see exactly how long that's taking, and then how long each query inside there is taking. You'd be able to narrow down into that. Whereas logs, I think, are only really for, there's one specific thing that happened in one point of time, and you just need some dumb information about that. Logs are generally easier to look at and look up as well. There's way more systems that are compatible with OpenTelemetry logging and being able to dive into those than they are tracing. So it kind of depends on your use case. Any other questions on that? Nope. Okay, so we're going to dive into metrics next. Metrics being, well, charts and graphs and things. So I have a little confession that I couldn't quite get the OpenTelemetry exporter for the metrics working for this demo. It's like almost there. There is a bug in one of the package repos that is being worked on right now. But in the meantime, we're just going to use Prometheus directly because it's pretty much the same. This is what it would have looked like if we had the OpenTelemetry exporter working. Our application would have pushed to the OpenTelemetry exporter, and that would have then pushed into that Docker image that would have handled it itself. What we're going to do is way, way simpler. We're just going to tell Prometheus to pull from our application and pull the metrics that it needs. So to get that working, the first thing we're going to do is we're going to set up a little bit of configuration for Prometheus. This comes in the form of a prometheus.yaml file. What we're going to do here is we're going to say that, hey, every 15 seconds we want you to scrape localhost port 8000 at this /metrics path. Every 15 seconds, like clockwork, you're going to go there, you're going to scrape that data and get all of the metrics that are available on that endpoint and come back every 15 seconds. So next what we need to do is we need to make that endpoint available inside our application. So we're going to install this PHP Prometheus client package, which is going to give us this kind of tooling. It will give us this collector registry in which we have to pass through a data store. So we're going to pass through Redis as a data store, and Redis is then going to hold our metrics for the meantime, just until we get them into Prometheus. So once we've done that, we're going to make that available inside our container, just so we can really easily use the same container registry across, or collector registry across our entire application really easily. So once we've done that, we can set up this metrics endpoint. So this is an example in like a Laravel route. We're just going to be rendering in a text format. We're going to get that registry and get the metric family samples, which sounds complex. This is basically just returning a string, which is all of the metrics that we're recording inside our application. We're going to take that and we're just going to return it as a response. That's all you really need to know. And then every 15 seconds, Prometheus is going to come along, and it's going to hit that, and it's going to read that text that's given in the response. So elsewhere in our application, we now need to start recording this kind of stuff. So we have our collector registry, and what we can do is call this getOrRegisterCounter method. And there's a couple of different variations of this method, but this is going to give us an object which is a counter. And a counter is a number that only goes up. Like the number of requests that you're making to an API. You're only ever going to be making more requests to an API. You're never going to have a negative number of requests. So it's only going to go up. So if we have this, we call the inc function to increment that counter by 1. You could also increment it by more than 1 if you wanted to. And that is going to make our metrics endpoint look a little bit like this. You'll see there's some stuff at the top where it's reporting the PHP version, which is just something that PHP package is doing for us. But this demo counter that we had here is down here. There's this optional help text that we defined, but it's also defining the type of this metric. So the telemetry times demo counter is a counter. And then the value of that counter is 1. And then maybe we call that code again, maybe we make another request to that API that we're trying to record the metrics for, and that counter is going to go up to 2. And we make another request, and it goes up to 3. And we make another, and it goes up to 9, because actually multiple requests happened at once. This is what Prometheus would be seeing. It's seeing the number increase, potentially exponentially, or with vast differences in between at every time. And one thing you'll notice here is there's no timestamps or anything in this file. So when Prometheus is scraping this data, it's not aware of exactly when every metric was added. All it's aware about is, oh, hey, at this point in time there were 9, at this point in time there were 45. Therefore, it figures out itself, as a time series database, hey, there were 34 things added to this counter between this point and this point, and it keeps track of that itself. So you don't have to keep track of all of the timestamps that happens. All you keep track of is a count of a number, and Prometheus will do the rest. So that number keeps going up. But there are other things that Prometheus can do, not just counters. There are 3 primary data types that it has. So one is counters, which are numbers that only go up, like the number of requests. You also have here gauges, and gauges are numbers that can go up or down. For example, the number of active connections you've got to another system. Depending on how many API requests you're making, depending on how many users are using your application, that might be really high, and then when all the users go away at night, that might be really low. So you can increase and decrease those. And then lastly, we have histograms, which are quite a little bit more complex, but basically they are 2 bits of data side by side. They are a number of observations and the sum of the value of those observations. So for example, the request duration, let's say a request took 2 seconds. Well, you might start off with a counter of 1 and a value of 2, which is 2 seconds. And then maybe the next request takes 3 seconds, so you might end up with a counter of 2 and a value of 5 seconds because it's added the 3 to the 2. And so what you can do with that information is really easily just divide the total, divide the sum of everything by the total, and then you get the average of how long are your requests taking on average, rather than specific information. So if logs and traces are for looking at really specific information at a specific point in time, metrics are more for a general overview of your system's health, not an individual request, just the overall health of it. What it can also do is it can split all of this data up into buckets. So instead of having just an overall number of requests and how long they're taking across your application, you might record separate bits of data. So any request that's taking between 0 and 0.1 seconds is going to go into one bucket. It's going to be recorded as one metric. Anything between 0.1 and 0.25 will go into another bucket. Between 0.25 and 0.5 will go into another bucket. And so you can see here we're observing 0.4. So if this was how long a request took, that would then end up in this 0.5 bucket because it's between 0.25 and 0.5. So you're not limited to just the overall look at your data. You can split it up however you want to get and hone in on whatever specifics you want. Now another thing all 3 of these data types can deal with are labels. And labels are basically like the context data we talked about before, where you can add additional contextual data. In this case, we're adding a client, a method, and a path into our counter, and they're going to be made available in Prometheus when we're searching for them later. So we've done that, and we've made a couple of requests, and this is what our metrics file looks like now. I'm going to scroll down a little bit, and you'll see here we have all of these different metrics across different things. So you can see here we've got like the number of requests to the comment API that were using the get method and that were using this article 1 path. Well, that's a count of 6,401. That's how many times we've got that article's comment. Kind of useful. You can also see here like, oh, this is how many times people have logged in, and this is how many times people have logged out. So you can start to use this to get the information that you might want that you might not have available elsewhere. But I do want to point out one thing, which is if you look at these lines where I've got an arrow here, all of these paths have something unique about them, which is this path has article/1, which is the ID of the article. This one has article/2, which is the ID of that article. This one down here has article ID 1 and then comment ID 1. And so what we're seeing here is our data isn't really normalized very well. We're going to end up with thousands and thousands of different unique metrics for every single article. And Prometheus can handle lots and lots of metrics, but just like you don't want to end up with n+1 queries in a database, you don't want to end up with lots of cardinality and lots of unique combinations of things in your metrics. If you can normalize something to something that's a little bit more useful, to the averages that you want, that's going to be really useful. So maybe don't use the path as one of the labels that are on your metrics, because that just might not work out well. So we're going to come back and we're going to use this information we've just got to make another middleware, the last one we're making. We're going to set up our labels here. I've added path here, but like I said, don't necessarily do that. It's not necessarily a good idea. It depends on what APIs you're calling and what you're doing. You just need to be a bit aware of the data that you're pulling in. We're going to start by recording the current time before the request was made. And then when we've got the response, we're going to find out the duration by taking the time, the current time at the point of the response, minus the point before it, and then we get a number that shows us how long something's taken. So we have the duration of how long that request took. And now we can also add some additional labels on the response as well. So we're going to add a label of the status code, and on a fail, we're going to add the status code as 0. And then what we can do inside our closure that is on a successful response or a failed response, we're going to get our collector registry, and we're going to get or register a histogram. And you can register a counter or a gauge or whatever you want, depends on what you're doing. But like I said, a histogram is 2 types of data. It is already a count, and it is already it's basically 2 counts side by side. So instead of recording a count of how many requests we're making, I could just take this and use the count on this to figure out how many requests were being made. So you can see here, I've named this metric Guzzle_seconds, which is the number of seconds it's taken to complete a request. And I'm recording that in lots of different buckets as well, so I can see roughly how long different requests are taking and how many requests are taking different amounts of time. So we're going to take that and we're going to observe that duration. And then we're going to come back and think about other things that we can do. So all I've done here is the request duration, but there's so many other metrics you can start to record. You can record the request duration, the size of the request, and the size of the response as well, because that might be really important for bandwidth limits on your system. If you're making thousands or millions of API requests as well, you might be thinking about DNS lookup time and connection time. Typically that's going to be in microseconds, but if that starts creeping up to 50 milliseconds every request, suddenly that can have a big impact on the overall performance of your system. So you can use this to start to record the metrics over time. And typically it's better to have more metrics that you don't need, just so you can look at them over the period of time where you didn't know it was a problem. So if you run into a new issue where, suddenly it seems like all requests are taking twice as long, if you have this information readily available, you have the historic data to be able to find out and track down where a problem happened. So we have that data. Prometheus every 15 seconds is going to be scraping that data, and we want to look at that in Prometheus with the help of Grafana. So again, we're going to come over to Explore in Grafana's menu. We're going to come to Metrics, and it's going to give us a nice little dashboard here that shows all of the metrics we have available. And you can tell there's different types of graphs available already. There's histograms being reported here, there's counts going up and down, there's gauges going up and down. Depending on what type of data you have, Grafana does a really good job of figuring out what's the best way I can display that for you with 0 effort. But what we really want to do is we want to come over to the Explore section again and set our data source to Prometheus, and then that will give us a metrics browser that we can use to write a Prometheus query. Again, it's very similar to low-key, very similar to tempo, but it's a different query syntax again. So we're going to start to type in the telemetry times, because that was the namespace that we gave all of our metrics in our application. And Grafana is really, really helpful. It's got a great UI. It's going to automatically complete for you and show you all of the metrics that you have available that is already recorded. So we're going to come down to this Guzzle seconds count, which is recorded here. And you can see it's given us this nice little graph here. It's showing us straight lines of all of the counts of how long something's taken. It's not necessarily so useful on itself. But what it says up here is, hey, this selected metric is a counter. Maybe you don't actually just want the raw count. Maybe you want to calculate the rate of the counter by adding the rate function. So you can click that, and it will automatically add this rate function around that metric. So now it's giving us a bumpy graph with lots of troughs and peaks, which is a little bit more useful because over a 1 minute average, we can see that the number of requests is, well, they're mostly taking 0.4 seconds. Nothing's really going over that 0.4 second mark, which is kind of helpful. But we can make this a little bit more useful as well. You see here we've got lots and lots of different lines on this, and we don't exactly know what they are. There's labels down here for what they are, but there's way too many of them. So what we're going to do is we're going to use the sum function and sum up all of those results together so that it gives us the total number of all of the requests that were being made. And now we can see all of that information here with all of our different API calls to different services and third parties all being collected together. And suddenly that's starting to look a little bit more useful. We can make it more useful by adding this by client section to the sum function. And so we're summing, but limiting it to each client. So here we've got a separate line for the auth service, the common API, newsletter signups, payment service, and search providers. And now we can start to see, we don't have 100 different lines here, we have like 5 different lines, and we can start to hone in on, well, we can see this API service that we're calling, we're making about, well, 4 times as many requests to this one as we are to one of the ones down here. So we can start to see how active our APIs are, what services we're calling more, and use that information however we see fit. One thing we can also do, if this is like way too jagged, there's like too many peaks and troughs, it's not really useful to see, you can come in and change the limit at the top here from being an average over 1 minute to being an average over 5 minutes. And that will basically average out all of the data that Prometheus has over a longer period of time, which will give you a more natural show of exactly how the data was looking over a longer period, rather than it constantly going up and down when one of those metrics changes, which is really useful depending on how long a time period you're looking at. If you're looking at, for example, 2 days worth of data, you probably don't need to report it every single minute, because then it's just going to be up and down every single minute, probably from 0 to 1 to 0 to 1 on lots of things. You probably want to average it out over maybe an hour or something instead. And you probably don't want to be doing this every single time you come in and you're looking for data. So what we're going to do, at the very top right there, we're going to add to dashboard, and Grafana is going to let us save this query and save the graph that we've created and put it on a dashboard for us to just go back to later down the line and use without having to remember the query. So this is one we built earlier. It's got a bunch of different dashboards, or a bunch of different charts and information on the same dashboard. So at the top here, we've got like the overall requests per second that we're making. At the top right, it's showing like the number of failed requests by each API client. Here's the total number of API requests by each API client. And you start to see this is really useful to just have at a glance if you need to see if something's gone wrong, because if this one that we're making a ton of requests to suddenly drops off and has 0, then something's maybe broken in our application, or maybe something's broken in the third party. What we've also got at the bottom here is a table with more raw information. So Grafana doesn't limit you to just showing graphs. It can display information basically however you want. It's a whole dashboard system. It's really useful. But one thing that's really useful with this is you can make links to other dashboards. So if I come down here and I click on one of these links, I'm going to go to another dashboard that's actually honed in on more specific information about just one of those APIs instead of all of them. Now I've got this dashboard, I can see, well, we're making 0.722 requests to this dashboard, and it's looking, well, not that good. We're getting nearly 40% of errors across all of our requests right now, which isn't great. So we can see, hey, this is something we need to look into. And I just want to go over some of Grafana's features again. So at the top right, you can automatically set how often it will refresh. So if you want to have this like up on a screen in an office or something, you can have it refresh every minute or every 5 seconds or however frequently you want to see the data, especially if you're really actively looking at something and trying to diagnose an issue. You can also come over here and set the time range, so you're not limited to just the last hour. However long you've stored data for, you can expand to that time range, and all of the charts on the dashboard are going to expand to show that time range as well. What we've also got set up at the top left here is a couple of custom ones. So we've set up a custom variable called the average. So like we had 1 minute and 5 minutes before, we've now got this variable where we can set the average, and all of the queries inside every single dashboard on this page is going to use that average. So I can change that and they will all change at the same time. I don't have to go and edit the query for 10 different charts just to get them to work the same way. And then at the very end here, I've also created a variable for the client name. So if we want to look at a different client, maybe not the comment API, if we wanted to look at the Stripe API, for example, or the payment API, we could just click on that and see the dashboards and the charts for that specific client. There's one other thing that I want to show, which I think might be a little bit hard to see here, but hopefully you can see this little line here. Can everyone see that? Yeah. So this is an annotation, and you'll see this on all of the charts on this page. This is something that my application has sent off when it was successfully deployed, sent an API call to Grafana itself and said, hey, there's a deploy that happened at this point. Here's an annotation for you. So we can link up that information about when our deployment happened into these graphs and start to see when an event happened and how that impacts our service. So in this case, we can see at the top right there, for example, a deployment happened and then suddenly the request number started to shoot up. It was really stable before, but now we're suddenly making way more requests. And if you look at that, it's actually going from 0.7 to about 0.8 requests per second, but that's only because we're looking at the last 15 minutes and it's over an average of 30 minutes. If we change the average down to 30 seconds, you'll see it's actually gone from about 1 request per second to about 2 requests per second. It's basically doubled the number of requests that we're making to this API since we made this one deployment. Now that we've seen that, we see there's a problem, and we can go in and think, hey, maybe we need to revert that last change that we made and look into that a bit more thoroughly and QA it before we push it out again. So you go and undeploy that, and you'll see the charts have another deployment on them, another deployment annotation, and then you can start to see they've come down again into what we expected before. And with this, you start to get a picture of how you can take all this information from different systems and put it together in a way that really lets you have a full-on view of your application and how good it is and how stable it is and if anything's going wrong and why something might have gone wrong. But realistically, you don't want to be sat there at your computer with one of these charts open all day, every day, just waiting for something to go wrong. So what we're going to look at next is something in Grafana called alerting, and it's really, really useful. First thing we're going to do is set up a contact point. In this case, I've set up a contact point. I'm saying to send an email to me. But if you want, there's so many other integrations. You can get it to send a Slack message to a certain channel, or a Discord message, or Teams chat, or something else. You can get it to raise a PagerDuty alert, or go to Incident.io, or even just send a webhook to any other service if you want to. But how do these contacts get triggered? When does a message get sent through one of those? We're going to set that up using an alert rule. And I've made one here called payments failing. Now down here in the query and alert conditions, I've selected a Prometheus as my database, and I've written a Prometheus query here that's basically figuring out the percentage of successful requests versus the percentage of failed requests, and we're saving that as a variable here. And then later down the line, we can take this and we can set the threshold. So if the number of successful payments is below 90%, well, then we want to be alerted. And you start to see how this is useful. But maybe you had one failed payment over a 5-minute period, and that's your average on your request, on your query, and that's maybe not useful because you don't want to get woken up at 4 a.m. by your phone going off from a PagerDuty alert just from there being a single failed request. So what you can do here is you can set how long something has to be failing. So you can say, oh hey, we need something to be failing for 5 minutes before we get alerted, or for 10 minutes, or for however long you want. So individual spikes and anomalies won't necessarily trigger someone to get contacted. And then we'll scroll down a little bit further and we can set the contact point that we set up earlier. So we tell it where this alert should go to. And you can also configure some additional stuff. So now you've got this view of your system where even back here where we were defining this Prometheus query, this could be related to the number of logs that you're getting, or how long traces are taking, or anything else that you can query in any of those 3 databases we looked at. And it's really, really useful. So we've looked at all of these different things today, including OpenTelemetry at the bottom there. We've looked at OpenTelemetry and how that's a data format you can use across all of your projects, and how you should just use it and install it because you get things for free, like the auto instrumentation. You can store your logs and look at them in Loki, store your traces in Tempo, and store your metrics in Prometheus. And Grafana gives you this really, really nice way to get all of this data together into one place, so you can use it to have a single view on your entire system or your entire company's systems, to be able to get free alerting for it, to know when something's gone wrong, to be able to just know when anything bad has happened, or even when something bad hasn't happened, you can use this to look for improvements. If your requests are taking too long, suddenly you've got traces you can use to dive into that and figure out, hey, how can I improve that SQL query? And yeah, if you're not already tracing your applications or recording some kind of telemetry, hopefully this has given you some inspiration to do it in some of your applications. But yeah, I've been Liam Hammett. It's been nice to talk to you. Any questions?
The Prometheus, is there a Grafana made alternative to that?
I don't know if they have one. They're quite ingrained with Prometheus itself because it's an open source project. They might have something themselves. So yeah, Grafana do also own Loki and Tempo. But yeah, I don't know if they have something else for Prometheus. Prometheus has pretty much been the standard for over a decade, and so OpenTelemetry metrics is actually built using Prometheus as the backbone of it, or using it as like the inspiration for the standard at least. Yeah.
What sort of, like that looks like it's doing some heavy number crunching. Does it need some server behind it to use it?
It depends. It depends how many metrics you're recording, really, because it doesn't store lots of information. It stores averages of little bits of information. It's pretty performant. You don't need a super oiled system to be able to run it. I would recommend though to run it on a separate system to your main server, just so if your main server goes down, you've still got your metrics to know when something happened. So I would separate it from your application if you could. And then you can scale that separately as well. Yeah.
So you've shown Prometheus getting metrics from your
In which case then sort of if you've got those microservices, you've got well different people writing those, you need to implement that and maybe different technologies. Could you also implement that tempo, because you've got the work that's been going around, say, tracers, say, for example, the time it took, that's already been put into tempo. Could you pull that out of tempo?
You mean pulling that out of tempo into logs or into something else?
So rather than saying, I want to calculate.
Good question.
the time, I'm going to push that up to 3.
I don't think you can, because they're essentially 3 separate things. So there might be some way you can like check the tempo data raw and put that in, but by default, OpenTelemetry, like the traces, metrics, and logs are basically 3 completely separate systems that just happen to point at the same place. But maybe that's available. I've not seen that myself.
I was going to ask, what's the actual benefit or use case in like the site application that when there was quite small, using all of those tools combined, or using something like Sentry, which is much out of the box, a lot of those things in a smaller version.
So yeah, there's a million other systems like this. Like there's like Sentry, there's Better Stack. There's so many. It's like the number one developer tooling thing that people do is observability of some kind. Sentry is pretty good at most of these things. It doesn't really excel in all of them necessarily, though, especially if you have like different systems with different requirements, and you don't necessarily have a Sentry integration, and you don't want to have to set up an API for that. Sentry has a lot of integrations, but not necessarily the best with lots of things. Sentry is also an open source thing. All of these tools are also open source and free to use. So it kind of depends what you want to use. Yeah. I think one of the advantages of this is with that Docker image, you can run that on your local machine and get that same information, whereas it's maybe a little bit harder to set up Sentry on your local machine for exception reporting and all the other telemetry you get. There are also other views you can get in Grafana. So there is something that does something similar to Sentry and like shows you exceptions that you're logging. There's like a different data format that's outside of the logging and tracing.
Did you just say Grafana is open source?
I meant free to use. I don't know if it's open source. There's parts of it that are open source at least.
Even free to use, I didn't know that. I used Grafana when it was before Influx, but it was like really real peaks and troughs to like the price.
Yeah, I mean, I think they have some enterprise stuff. So if you wanted it hosted, they offer Grafana hosted. They have some features gated behind like enterprise payments, I think. But for the most part, you can just use it for free. And yeah. Anyone else? Yeah.
So Laravel Telescope, is that using the same protocols as this, or is it completely different?
No, Laravel Telescope doesn't use OpenTelemetry. But
It's going to be running on a middleware there, right? Or is it using something like the hooks that Grafana uses?
Are you asking about Telescope specifically, or?
No, I was just wondering, because obviously I've come across Telescope, I've come across Grafana in the pool of stuff we use along the Datadog, so it's sort of, obviously Telescope is really helpful, really close to it. It's not, well, I've not used it for sort of application monitoring, because obviously it sits on a pod with an app, rather than you're monitoring over all your apps or over all your instances or something.
Yeah. So I think it depends exactly what you want to do. The OpenTelemetry auto-instrumentation package for Laravel, I think does basically everything that Telescope does out of the box. It just puts it in a different format. It's maybe not as tightly integrated to Telescope, but yeah, it should get you most of the way there. Anyone else?
AI supporting Grafana. Is there any sort of
I have no idea about AI supporting Grafana. Sorry.
This may not be relevant to
to the situation it's intended to, this type of situation. Does Grafana cater to live testing? Because there was a situation ages ago when I haven't had a kind of adaptive spanner, and my search logs for I had a search form for search for prisons and things, and I'd like to log in to see if they were searching for new prisons I hadn't heard of that I could add to my system. And I noticed one day the server ran out of space because it was getting so many queries, so I decided to look live at what was going on. And every few minutes I was getting a normal query, and then every second I was getting this one IP sending me spam into the search form. And I thought, well, I traced that to somewhere in Russia, and I thought, well, I'll block you. And immediately I blocked that IP, switched to another IP. And I wouldn't have noticed that if I wasn't testing live. So is there any kind of, can you do it live?
I'm not exactly sure I understand what you want Grafana to do there. Just to be able to search for anomalies in the data? Like if one user is searching for more stuff, or?
Yes, but I wouldn't have known that it was a reactive spammer if I hadn't experimented with it live. If I waited for it, made an alteration to the code, and then waited for it to collect that data, and then another alteration, it would have been a much longer process.
Yeah, well, I mean, yeah, so the Grafana will just work with the data it's got, so it depends when you make the change in your code, but yeah, it will basically report the changes immediately, depending on the parameters you've set up in your query. So it can show the information basically immediately, or you could set up alerting to tell you when that happens or if something changes. Okay. I think that's everyone. Oh, no, one more. No? Okay.